channels, for example, the TV, radio, newspaper. Okay, so it means these three columns refer to the input. Yeah, and the last column is refer to the output or the label. Okay. So you have to separate, right? And the concept you have learned before. You have to separate. First three columns is X input, right? And the last column is mean label of Y variable. Okay. So in this case, I try to plot the graph. Actually, the graph is not the same or similar for the previous one because I use another library. As you can see, I import the Seaborn. It is the additional one. It's not you know only the Matplotlib, right? The Matplotlib library. In every time we use Matplotlib for plotting the graph or showing the graph. By the way, we have another library that also can show all the data visualization. The name is Seaborn. Okay? If you interest in some graphic or in some data visualization style, it's more beautiful than the Matplotlib style. So you can visit the website of the Seaborn to find the example. Okay? And also I try to use this one to show you about the we call it pair plot. Okay? Because you know we have three input parameters, right? And we have one label. So I try to separate and plotting the graph between TV and sale, newspaper and sale, and radio and sale. Okay, so as you can see, this y-axis is referred to the sale, right? The label, and we separate into three different inputs between TV, radio, and newspaper. Again, plot the graph to see the trend of the data. Okay? Because we cannot plot the, you know, this table is referred to the 4D, right? It's not 3D. 3D is mean, okay, only three columns. If you have three columns, you can plot like scatter plot 3D. But in this case, we have no scatter plot in 4D. Yeah. So if you want to find some relationship or if you want to plot the graph of the 4D, it's impossible. Okay. So I try to change the style for plotting. And then, okay, it's the step for separate X and Y, okay? X is mean these three columns, okay? I correct it into the term of X variable, okay? And Y is referred to the sales column, yeah? Don't worry, I will send you later about this example, okay? You can study by yourself again about my coding example. Okay. So this step is just separate X and Y. Okay. And then you can show the information of X, show Y also. And then it gives the time for creating the models. Okay. Right now, we are focusing on the linear regression. Actually, it is the same concept of the linear regression because the linear regression, as you have learned before, in the last week. Actually, this function is not only simple linear regression, but you can apply many input, like the multiple input, multiple linear regression. In this case, you can call the function as same as the previous one. But okay. But you know that X. Right now, X is not only one input, right? X, you are correcting three inputs in terms of X, but you can do it as same as the same process previously. By the way, if you learning it finish, you can print out the coefficient and intercept as the same concept previous also. And by the way, the coefficient is gonna print out three coefficients. Okay. If you remember the equations the equation of the multiple linear. So the multiple linear is cell, right? If you focus on cell, cell is mean output, right? Cell equal theta 0 plus theta 1 TV, right? Plus theta 2 radio plus theta 3 of new errors. Okay, so we got the three of coefficient in front of TV, radio, and new errors, right? This is the theta 1, theta 2, theta 3, and if you print out, or if you want to see the intercept of the model, it's going to print out the value of theta 0. This one is theta 0. So from this equation, you can make the models by using these parameters. Okay. Okay. Yes. Actually, I already showed my models in this block. Okay, and try to print out the answer of the models according to the coefficient I print before. Okay. So it means if you have the company, if you have your own company and you want to know that how should we spend the money for advertisement, right? You can use this model and you can input the number or input the how much the money you want to spend for advertising on TV, radio, newspaper, right? What happens if our company don't want to spend the money for TV, radio, newspaper? So the output is only 4.6, right? Maybe 4.6 is like 4.6 million Thai baht, for example. It means if your company don't do anything in that year, maybe you can get at least 4.6 million Thai baht for the sales. By the way, if you want to spend the money for something, which one? What do you think? Which one is have the? It's not necessary. It's not important. If you are the own, if it is your own company, which one? TV, radio, newspaper. Which one we should not spend the money for advertising? Newspaper, right? Because as you can see, the coefficient is very less number, right? So it means even you spend a lot of money, but this term of this one is going to return very low output or very low number, right? For example, if you spend the money for newspaper 1, radio 1, TV 1, but this term of them is going to return very less. So it's not important. If I am the boss in this company, maybe I think, okay, this one is suitable because it's return the highest benefit for, if you compare with the TV, radio, newspaper, this one is return the highest value. Right? So this is the meaning of the multiple linear regression and analysis. You can analyze what the parameter you should increase or you should decrease or you should remove it. Okay. Okay, for the evaluating model, so you can bring out the R square, right? The R square is, can tell us about the the model is suitable for your data set or not, right? If you print out this one, you can see it's almost 1, right? 0.9 something, so it means, okay, it's quite good model for predicting your data, okay? And also, if you want to print out the error, we have also the error function, okay, as same as the previous example and show you not so much error. The last time we had another homework about the root mean square, some square error, right? What is the difference or what is the advantage or disadvantage for mean square error, some square error, root mean square error, right? I will check later. Have you done the second question? I will check later. Because in some cost function is very effective if you have many outliers, about the noise of your data. Some cost function is very sensitive. If you have done your homework, I will check later. Okay. And this one is show you about the predicting of the value. For example, if you want to spend the money for TV, 10 million baht, and zero for radio and newspaper, 0 baht. It means your company will be get the sales around 5.1 million baht, for example. And this is the example for multiple linear regression. Okay. Okay, so right now I have 2 time left. As I told you, I try to finish the content of neural network, okay, because we have another big topic and important topic about the artificial neural network. Yeah, I try to finish the artificial neural network in 2 time left. Okay, and also I could be explain you about a little bit deep learning also, okay, because you have to learn about the neural network, and then I will explain you about the deep learning a little bit, or like the convolution neural network. By the way, we still on the topic of the classification by using the KNN. Actually, today my health condition is not good. Yeah, because my son he got sick. Yeah, also like affect to my health condition, but not so much. Yeah, the last time we have learned about the KNN technique, right? If you remember that, the KNN technique is the technique that can be predict the label for the unknown data. Okay. Okay. For example, if you have 3 groups, like the label of yellow, label of green, and label of the orange one, and then you have the new one that you don't know. It should be the green, yellow, or orange. The concept is distance measurement. Okay, you have to measure the distance from the group, the unknown point to all the points you have in the data set. Okay, after measuring the distance by using Euclidean distance or Manhattan distance, you can select one, and then you select and calculate the distance finish. You have to arrange the minimum distance to maximum distance, right? Minimum distance or small distance is mean that point is close or very similar to the unknown data, right? But if the distance is far away from your unknown data, it means that data you compare is very different or is totally different from your unknown data. So you have to arrange the distance from the shortest one to the maximum one. Okay? And then you have to vote. Like before voting, you have to select how many K, right? K and how many K you want to focus. For example, in this case, you have want to focus 3, K equal 3. It means you want to focus on the first 3 shortest distance. Okay, in this case, you can see that the first 3, it has the 2 times of yellow and only 1 time for green. So the winner it is the yellow. So if you find the winner as the yellow, it means the unknown data is should be assigned to the yellow group or yellow label. Okay. So that is the last week content. And also I also show you the example about it when we changing the K. Sometimes when we change the K parameter, the label or the output is going to be changed. Okay, so it is a one point or one thing that you have to concern about this one. Okay, so okay, we move on to model evaluation today. Okay, so everyone knows about how the K-in works, right? How does the K-in works? By the way, okay, you know that the number of K can be affected to the output. So that's why we have to know how should we do the model evaluation. Yeah, because we don't know this model is good enough or like if you adjust K equal 3 and you adjust K equal 5, which model is going to be better? Yeah, so we have to learn about it. Yeah, model evaluation. Yes, the concept is very easy because you know before training the model, if you remember, we have to separate the data set, right? Training data set and testing data set. So the concept, we have to compare between the actual data, the actual answer, okay, the correct answer you keep in the testing set. Okay. For example, okay, if this one is your testing data, you keep in the 20% or 30% for testing data set. In the testing data set, we have features, right? For example, this is the iris data set. I think you have done in some homework about the iris data set that contain the iris length, like the like sample and petal width and length, right? And then you want to predict the class of iris. Yeah, and in this example, we have the 3 different classes of the iris. Okay. For example, you keep this one in the testing set, and when you test it, you just pick up the features, okay, and send it to the model. For example, if you pick this example of your data set, the correct answer or the actual answer, it must be Set-Cosine iris type. This is the correct one. Okay? If you send your feature with this number, okay, to the model one, okay, if the model predict as Set-Cosine, it means okay, it's correct because you comply with the real one or the correct one. By the way, if your model is predict with the answer as Versio color is another type of the iris, it means wrong, right? So if you have, for example, you have 150 data, it means look like you have you want to test the final exam with the 150 data questions. So you have to ask your model 150 questions. Okay, and every time you ask the model, you will know the answer and you can compare the answer. Okay, so it means with this concept, you can find or you can calculate the accuracy, right? For example, if you have 150 data and your model can get the correct answer 150 times, it means your model is perfect, 100% accuracy, right? But if you compare the model sometimes the model is correct is wrong answer, is get the wrong answer, so you can know how many times that the model return the wrong answer and then you can calculate the accuracy. Okay, and this one is the concept. As I told you before, that's why we have to correct and separate the training set and test set, right? If you remember the last time we talked about this one. Okay. We need to keep training set, for example, 70% for training and keep it 30% for testing. Okay. This is the unbiased solution. Okay. Because your model it never see the test set before. Okay. This means if they can do the test, if they can correct or predict the testing model with the high accuracy, that's why we can get the good model also. Okay. Okay, and sometimes when you learning the model, okay, maybe yes, I think this concept you can have or you can see in some model that maybe about the YOLO that I'm gonna assign you. The YOLO you have to separate and okay, maybe you can see in the tutorial or the website. Some website or some tutorial is gonna separate the folder. One folder, maybe it has the folder of training and folder of test. Okay, in the computer we have a folder, right? And the folder of training, maybe they correct the training and validation set. Okay, because the training set is gonna train the model. But you know, when you train the model, you will not train only one time. Maybe the first time that the model learn, when the model finish learning one round, you can get the weight, right? At the concept, at the same as the regression. You train it one round, you can get the weight, right? But the weight, it doesn't like high accuracy, it will be high error, right? When it's high error, you have to train it again, right? When you train it again, every time that you train the model, we have to use another subset we call the validation set for test the model, right? Every time, one time, two times, three times, until we don't know how many times, but some models take a long time for training, maybe 1,000 times for training. Okay, so you know that every time they're training the model, they get we hope that we're gonna receive the lower error in every time they train it, right? So we assume that okay, we got the good one of the model. You can finish your training, and then if you believe that model is quite good, you can get the model we call the learned model. Okay, and then you can use the test set that you keep before and test it again. Okay. So this is the accuracy estimate. Okay. This is the concept of the model evaluation. Maybe you might be more understand when you training the YOLO. Okay, because you will see folder. Maybe you have the folder of testing, validation, and folder of training separately, and you have to know that what is the meaning of training set, validation set, and test set. Okay. This one is the meaning or the definition. I give the training set, validation set, and test set for you in the slides. Okay. By the way, the accuracy is the one way for evaluate the models. Okay. The accuracy equation is come from the correct prediction. Like how many times, right? How many times your model return the correct answer, right? It is the meaning of correct predict. Over the or it means like how many questions you ask to the model. Okay, for example, if your model have 90 times for the correct answer, okay, from the question is 100 questions. So in this case, it means your model have accuracy 0.9. Okay, it means if you multiply with 100, it means 90%. Okay, it means your model have the high accuracy of the 90%. Okay, this is the one of model evaluation. Okay, this one also very important because this one we call the confusion matrix. It's very important for the classification. Okay, just now or not just now, like the last week we have learned about the regression. The regression, the value that is important is R squared, right? Trying to measure or testing the performance of the model with the R squared. But in case of the classification, we always use the confusion matrix for showing your performance of the prediction from the model. Okay, this is the confusion matrix. The confusion matrix can tell us about the many parameters like the accuracy, like the precision, recall, and everyone score. This is the important thing for the classification. So as you can see the matrix, okay, the matrix is added. For example, this is the 2 by 2. For example, you have only two classes between positive and negative. Okay. Or to make you more understand, for example, if you want to predict the answer only cat and dog, you want to separate is it cat or dog. Okay. For example, this is the positive is mean cat and positive is mean dog. For example, and then in this column it is referred to the true class. Okay, and the row is mean predicted class. It means the answer from the row, the horizontal line here is come from the model prediction. Okay, it means if you predict, if your model predict cat, okay. For example, if you have 10 pictures of cat, okay, okay. If you have 10 pictures of cat for testing your model, if your model predict the cat 10 times, it means TP equal 10, right? 3P is mean true positive, okay? That means you have 10 times of cat for testing, and your model also predict the cat 10 times. It's perfect, right? Also, if you have 10 times or 10 image of dogs, and you give the model predict, and your model predict this is dog, right? You have 10 times. and your model predict the dot as 10. It means your model predict correctly, perfect, right? 10 times perfect. So this one we call the true negative. Okay. By the way, okay. Another case, like you have 10 images of cat, okay, but your model predict correctly only 8 times. It means actually it should be 10 times here, right? But we have only 8 times correct for the cat prediction. It means true positive. True positive is 8, right? 8. And it has 2 times the model predict wrong, right? Wrong predict 2 times. It means actually it should be dog, but your model predict as cat, right? Actually it should be dog, but your model predict as cat. So in this case we call Fn, okay, false negative. Okay, so if Fn equal to Pp equal 8, okay, and also if you have the 10 times of dog image, and it has only 5 times correct answer from your model, it means 2 negative, right? Because actually it should be dog, and your model predict as dog. So this one is 2 negative 5, and also we have 5 times wrong answer. So it means false negative. It means dog. Because actually it should be negative, but your model predict as positive, right? So that is the confusion matrix. Okay. You know, when I explain this one, I also feel confused in some time because it has 2 columns. It has the 2 dimensions we have to consider. Okay. And I will let you know what is the result from this confusion matrix we can get. Okay. Okay, for more example, to make you more understand, this is the situation that the patient, okay, like the person who go to the hospital, okay, and you know, we have 2 class, okay, true positive, true and false, okay, and for example, if this woman go to the hospital, okay, with the true, how should I say, tummy, right, like this. So the doctor predict, okay, you have the pregnant. So it's be correct, right? It's okay, it's correct one. But this situation, yes, this situation, for example, okay, this man come to the hospital and the doctor predict as or you have the pregnant, but it's impossible, right? So this one we call the false positive, okay? And this one, okay, this woman comes again, but this hospital predict that, okay, you are not pregnant. Maybe you only have a fat, a lot of fat. Just kidding. Okay, and this situation is correct because, okay, maybe you are not pregnant because you are the man. Okay, so this one is look like the confusion matrix. Okay, in the concept it look like this. You know, but maybe one day, not only 2 persons come to hospital, maybe you have 100 persons and you have to predict some disease of the person. Sometimes the doctor predict correct, sometimes doctor get the wrong predict. Okay, so we can correct and record the how many times correct, how many times confused, okay, to get the confusion matrix. Yes, and sometimes you know we have more than 2 classes. Or for example, talk about the high-risk data set before, we have 3 classes of the Sentosa, high-risk, O colors, and clinical high-risk. So you can also do the confusion matrix with the 3 by 3 like this. But if you want to get the good model, it means you need the diagonal of direction confusion matrix with the high value, right? But sometimes maybe you can get the other part of the confusion matrix as the different number. It depends on the confusion of your model. Okay. Yes, and this one is show you the difference between accuracy and precision. Okay, because from the confusion matrix just now we can calculate accuracy and also we can calculate the precision. Okay, if we talk about the accuracy and precision, you can see that if you have the gun, right, you can fire the gun. If you fire the gun, you can get the result. If you get the result like this, it means you are the good gunner because you get the high accuracy and high precision. Precision is mean when you do something repeatedly, your answer is going to be same, almost same. Okay, we call the high precision. Okay, let's take a look at this example. If you have the answer of your target like this, it means you are the good precision, right? Because every time you find a gun, you can get the almost target. Okay, but you are find the gun with the low accuracy because if the high accuracy, it means you are should get the center, right? The center or the correct one, but it's not the low accuracy but high precision. Yeah, so let's take a look at this one. It is the high accuracy because it is almost the center of your target, but it's like this split out a little bit around the target. So this one is example of the low precision but high accuracy. And the last one is the low of both accuracy and precision. Okay, because every time it's like the unpredictable answer. Like you have the low accuracy and precision. So which one we want the model get this one, right? Because we want the model have the high accuracy and high precision. Okay. Yes, when you want to make some devices also, for example, if you have the like the weight scale, the weight scale. In my case, if I have the weight scale and I try to measure my weight, the first time the weight scale tell me like my weight is 150 kilogram, and I measure it again. Okay, 150.1 kilogram. I do it again. 149.9 kilogram. So this means this weight scale it gives the low accuracy but high precision, right? Because when I do it repeatedly, it is almost the same value, but I am not like 150 kilogram exactly, right? So this is the meaning when you want to make the devices or everything in terms of the engineering product or everything, you have to measure the accuracy and precision, right? It means refer that your product is good or bad. Okay, from the confusion matrix, okay, we can calculate the parameters. For example, precision, we call F1 score with the different configuration. For example, if you want to calculate the precision, okay, we have the precision and we call between positive and negative class. Okay, if you focus on the precision on positive class, you have to calculate with the 2 positive divided 2 positive and 4 positive. Okay. So this is the equation for each one. Okay. Yes. Of course, if it includes my final exam, okay, I will give you the equation. You don't want to remember the equation here. Okay. So my examination, I don't want you to remember the things like this, like the equation. If it includes the final exam, I will give you all the equation. You just understand the concept, you just understand the solution, that's enough. And the equation, you don't need to remember anything. Okay? And also F1 score is important because the F1 score is look like the ratio between the recall and precision of the model. If the F1 score is close to 1, it means like you are got the good model. Okay. If the F1 score close to 0, it means your model is bad. Okay. Let's take a look example. For example, if you have the your confusion matrix after you testing the model. For example, you test the model and you get like 2 positive, 3, 2 negative, 4. Okay. 4 positive, 2 and 4 negative, 1 like this. Okay. You can use this number, okay, and then take it to the equation to calculate the accuracy. Okay. If you talk about the accuracy, what is the accuracy? The accuracy is how many times that your model predict correctly. Right? In this case, how many times correctly? 3 and 4. This one is mean your model predict correct. Okay, it's 7, right? And divided the number of testing. Okay, the number of your test it means all of this one. Okay, you can sum up all of this number. This means like you have 10 questions, but it has only 3 times and 4 times your model do it correctly. So that's why we can get the accuracy from the confusion matrix as well. And also from the previous slides, I refer to precision recall like this. Okay, between positive class and negative class, you can take that equation to calculate something like this, and you can see that the F1 score 0.6 and 0.7 for the positive and negative. So it means that your model is a little bit better in case of the negative prediction because the F1 score is higher the positive class, right? Because you know sometimes your model is quite good in the negative prediction or positive prediction is not the same. Some like for example, if your model predict only cat and dog, you know, maybe you can get the F1 score of the cat class 0.9, but the F1 score of the dog class you get 0.1. It means your model is stupid on the dog prediction, but very clever when the model predicts the cat class, right? So it can get you the information something like this. Okay? It can analyze not only the accuracy, because maybe the model is high accuracy, but when you analyze in the deeper detail, you can see that okay, it's quite good in the class A, but it's quite bad, a little bit bad for the class B or class C, something like this. Okay. So this is the advantage and the benefit of the confusion matrix for the model evaluation. Okay. because okay. For example, you have the data set. Okay, for example, if this one is your 100% data set, okay, and as I told you that we should separate 70% or 80% for training and 20 or 30% for testing, right? Okay, someone separate 70 and 30 like this. This one for training, this one for testing. It means that this 30% is gonna test your model, right? And your model might be predict correctly, for example, 80% accuracy. Okay? There is no problem. It's okay if you do like this. If you want to do like this, it's okay. Okay, but it has some problem, or not problem, some like we call the variance of the answer. For example, if I give you someone or some student separate 30%. Okay, someone said like I need only 30% here and 70% testing here. It's different. Like I give you the different question, right? Different question of your exam. Maybe this one, this student can do very well for this question, but I separate 30% for another person, but different question, right? Like this, and then they test the model. Maybe the model get the correct answer, like 70% accuracy, right? And someone said, I don't want to separate like this, I want to separate like randomly, like this, like you pick up randomly 30% and testing the model. And the model get the answer like 99%, right? So it has the variance of the prediction output. If you separate with the different question, different testing set. So that's why we have the solution of the cross validation. This is the one solution that can handle about this situation of the training and testing set. Okay, because yes, we try to reducing the variance of accuracy. Okay. So what is the concept? Let's take a look. This one is a little bit details. In deep detail. For example, this is the 100% of your data set. Okay, like this. At 100%, but in the cross validation concept, they try to separate with the different parts. For example, if you have to define it, how many parts you want with the k number. For example, they usually represent by 5 or 10. If you define k equal 5, it's gonna separate the data set at the 5 equally. Okay, the same percentage with the 5 part. After that, okay, you have 5 data sets. Okay, and then the first time maybe you can keep the first part like 20%. Okay, if you have 100%, it means 20%, 20%, 20%, yeah. You have 20% for testing and you keep another 80% here for training. And you test it to get the accuracy as like 80% for the accuracy when you get 80%. And then you do it again with the second part. Okay, and then you use the other part for training, and then you get the accuracy to maybe 75% accuracy, for example, and then you do it like this again until the last time. You have the 5 accuracy. Okay, when you got 5 accuracy with the different training set and test set, okay, you can find the averaging of the accuracy. Okay. So it is the suitable way for estimate the accuracy of your model. Okay. It's better than this one, but this one that's okay. It's not wrong because many research they do like this. Okay, it's not wrong. It's okay. But if you want to get the strong answer, okay, maybe you can do the cross validation. Okay. Okay, I think we finished the content for today, but we have another part of the implementation in Python. Okay. We're gonna do some exercise of the Python language with this data set. Yeah. This data set, as I showed you the last week about the diary. Yeah. And diary data set, I give you in the Google Classroom. Right. I'm not sure. You can check in the Google Classroom that I already uploaded this file for you or not. Take a break for implementation. Take a break 10 minutes. If you have the question
อ้โอ้อ๋อชมพอไม่ติดไม่รู้ทำไมวัดปับฟักทำไมมันดึงมันไม่ได้อะอะไรอะ What the hell What the hell What the hell What the hell ต้องมีรอยสักครั้งมาแทนแทนแทนหายไปแล้วสับ
assign the assignment, okay, about the YOLO, as I told you before. And we have three main tasks about the object detection, like object segmentation, object orientation. Okay. So I think all of you will have the members in the group as same the previous assignment, right? Or you want to change the members? The same members, the last assignment, right? Okay. Okay. So we have one group, two groups. You DBL, 1, 2, 3, 4, and you 5. Oh, you are the same group, right? 4, 5. Oh, 1, 2, 3, 4, 5, 6 group. Maybe 7 group.เราดูกับโรมันใช่ไหมอันนี้หนึ่งกลุ่มสองกลุ่ม อันนึงกลุ่มเป็นตัวแทนเพื่อนนะ ตัวแทนน้องนะ3 กลุ่ม 4 อันนี้ 4 นะ
เอานี้คุณเดียว
กับ4 5
คนมี
อันนี้ 6 อันนั้น 7 7 group. Who are the first one? You are the first one. Okay, I'm gonna random call. Okay, you get the object orientation.
ไม่ใช่
G, right? Right? Okay.
green green cross
And the next one, Roman. Your book. Orientation.
first
One, two, three, four, five, six, seven. Orientation one gone. Okay. So the next one is Roman. Okay. YOLO E. It's the new version. I don't know what is the YOLO E.
เอา
You have to study yourself.
เอา the latest version
Hmm?
เอาเวอร์ชันล่าสุดใช่ไหมครับ
เดี๋ยวบอกมันมีเนี่ยอยู่ในเว็บเดี๋ยวอธิบายว่าเดี๋ยวอาจจะแอดไฟล์ดีเทลให้ฟัง
โอเค
YOLO E.
level
ใครนะวงเก่งใช่ปะหรือว่าโรมัน
Rome ต้นกล้าต้นกล้า
ที่จริง
พวัต
เพราะว่า
ครับ
นะเป็นระดับแรกนะ
ได้ประมาณประมาณ
next group
เออ
we're gonna be the next group object segmentation
ไม่
ชื่ออะไรนะ ต้องเริ่มยาวไหม
It's a lot.
next
It's a lot.
next is your group
The fuck?
okay
Check this out.
detection object detection
Test out your shop.
okay object detection ชื่ออะไรนะ
คนกับผู้ชาย
ตัดลง
แล้ว
correct object detection right you got object detection right or orientation you got object orientation yeah I wrong I know your name orientation right yeah sorry วัดพระคนใช่ไหมวัดคนนะ
ด้วย
พุทธอีกสองกลุ่มไม่มาก็เอ้ยอีกกลุ่มนึงมาอยู่เนาะ
Two.
segmentation object segmentation ชื่ออะไรนะ
นัทพลกับวิวิ
นัท
นัทพล
นัทคน
N A T V O
ชื่อคุณอินเดีย
A T A
เป็นแฟนกูเป็นที่ใช่ใช่ไหม
คน
ว่าวิวิ
Stop
V I
อันนี้เหลือสองกลุ่มเฮ้ยเหลือส
ส
อ
อง ง
กลุ่
นี้
ม
ตกใจตาย
ดูนะเอาไงดี
อะไรนะ
เราเป็นกลุ่มไหนกลุ่มผู้หญิงสุดาไม่เชื่อเลยนะ
ที่ดารา
สุ
ดา
ดา
ราเขาเข้าใจ
segmentation นะที่ดาใช่ไหมกับใคร
กับคนเข้าใจ
กด
คนเข้าใจ
วัดเพราะฉะนั้นกลุ่มสุดท้ายที่เหลือคือชื่ออะไรนะจำไม่ได้นั่นแหละเดี๋ยวผมไปดูเองก็เหลือใครก็ไม่รู้สองเท่านั้นโอเค so I will talk briefly again about the assignment tool. Okay, for example, if you got the topic like object detection, okay, maybe you can select the version you want. Okay, but some version of the YOLO, some version like for example version 6, the version 6 it has the task only object detection. You know, for example, if you got the object orientation, you have to see the you have to find what the version it has the task of the object orientation. Okay, and in case of you got the object detection, you can select the one you want. Okay, but you have to study by yourself. Okay, like what is the like V6N, V6S, M, L, X. It has the many subversion here, okay, but it has the meaning. Actually, it is the size of the model. It's the size, like you have to share like size S, M, L, XL, okay. But you have to study yourself again and you select one or more. I will tell you later. Maybe I want you to select two models and train it and compare which model it is. better in terms of the accuracy, which model is better in terms of the like the time processing, maybe two models comparison. For example, if you have the topic like object detection, maybe you select the V6 and V8, right, and then training the same thing. You test the same thing, but what is the difference? Right? Something like this. But don't worry, I will tell you about the details of the report or the video, the short video that you have to submit in the Google Classroom again.
Short video, okay, fine.
But the concept is look like this, okay?
It doesn't mean
Each group it has the different parts,
please.
okay? But you have to select the I'm not sure like the orientation. The orientation, object orientation is in the V8. In the V8 it has the detection, orientation, cross wheel, post, so on, okay? But maybe you have to select. Let me think, maybe I need you to select at least two models comparison. And also when you training to get the result, I want you to know about the ways that compare between the result. Okay, maybe you have to understand about some graphs. Okay, like for example this one. Maybe you when you finish training, you can get some graphs of your model evaluation, and then you have to explain what is the meaning of the graph, why you stop, why you should stop this epoch, why you don't train it for the 10 times or 1,000 times, what is why you have to stop for training here. Maybe you have to understand something like this and explain in the report. Okay. Okay. So come back to our implementation. Okay, I will inform the details of the assignment 2 again. Yeah, so come back to our contents. So this is the example of the KNN classification. Okay, we try to use the data set. I think everyone has the data set. This one, right? The Dynamic data set. That the Dynamic data set it has the many columns. Okay, like how many times practice, the plasma and the blood pressure, skin and the insulin, the mass and so on. Okay, we have a lot of data about the patient. Maybe this one is still the free data set that I downloaded from the website and the database from the India. Okay. Maybe I already tell you that we have the website like the Gecko, right?
Gecko.
Maybe it has the many free data set. Okay. Because that the machine learning or the AI has a problem about the data set. If you want to train the model but you don't have the data set you cannot train any model. So this website is Gecko. Gecko is the website that has the data set, right? Can go to the website and download the data set you want. Okay. For example, this one is the medical insurance cost data set, like the GDP per country 2020 to 2025. Yeah, and a lot of data set free for you. You can download and learning it by yourself. Ask me, like I download the diabetes data set, okay, from the Gecko also, and okay. So right now, okay, come back to our content. You can see that, okay, we have a lot of features, right? And we have one column for label. The label is the answer of the patient get class 1 or class 0. Okay, class 1 maybe refer to the negative or positive and okay. Okay, maybe negative and 0 is positive. For example, okay, it means the diabetes or not. Okay. After that, it is the time for the data preparation. Okay, data preparation. In this case, I'm trying to separate x and y. Okay, x and y. X is in features, right? The features. So we have how many features? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 features. Okay. So the Python style. Now we correct it in the array pattern. Okay. And it's like the 2 dimension of arrays. Okay. The array has the 2 dimensions between row and column. And this one is mean you want to correct the whole rows. Okay, the whole rows. But you want to select the data from index 0 until index 7. Okay, because the Python, when you writing the code like this, it means we will stop at the column before your number input, right? It means 0 to 7. So that's why this one is index 0, right? Index 1, 2, 3, 4, 5, 6, 7. Right? This is index 7. So it's going to keep the x-axis in the row or column. Roman, you're going to go back.
7, 6, 5, 4, 3, 2, 1.
And you want to keep it in the or the row.
0 or
Okay.
5.
By the way, y. We have go to the hospital. I
Yeah.
don't know. Okay, so
Doctor.
the y is mean
Yeah.
label, right? The label we want to keep it only the this is the index 0, right? Until index 7 and this is the index 8. Okay, that's why we have the code like this because you want to keep all the rows. But you want to keep it only the index 8 of the column. Okay. And then you can run it for seeing the yes. So right now we have a feature. For example, you want to see the first row of your feature, and the labels from index 0 until index 9. Okay, you want to show the detail of your label from index 0 to index 9, and this is the x shape and y shape to print it out about how many data for x and y. Okay, so you can see that the x it is the 768 rows. Okay, and you have 8 columns. You have 8 columns and 760 around. Okay, and you have the y shape. It means you have the answer at the same input rows. Okay. And then it is the step for splitting data. Okay. In this step, you have to test and train split at the same concept as the regression. You have to splitting out the, for example, 70% and 30% for test and train. Okay. In this case, if you define test size as 0.3 is mean you keep 30% for testing. Okay? Keep the 30% for testing. Okay, after that, it's going to return 4 main parameters like X-train, X-test, right? The features of training and testing and the level of training and testing. Okay, if you print out these cells or this block of my code, you can see you will have around 537 for training. Okay, and you have testing or you have the question to test your model around 231 questions for test your model in the final answer. Okay. So before training the model, maybe we have the standardization, right? The standardization is the process of like changing the scale of your data set, because as you know, each column will have the different scale, right? If we talk about the number of pages, the scale is 0 to 17, right? And if you talk about the plasma glucose concentration, the value is quite wide, wider than the previous one. It has a different scale. So to make the model training better, you should standard or you should do the standardization to make your data set scale at the same range. Okay? So that's why we need to do this one as before your training. Okay? But I think you have done this one in the many previous examples, right? And then you can get the scale train and test. Okay. As you can see, when you print out, the data is going to be changed. The feature of this one is already changed because it already processed about the standardization. Okay. Step 3, reduce the time for model training and testing. The important function is the k-neighbor classifier. Okay, and the capital letter of K and N, okay, with the capital of C classifier. Okay. So this one should be 3, okay? You can try it. You can try the parameter here is mean how many K. And the concept I taught you in the slides, like if you define 3, it means you want to focus on the first 3 short tests this time. Okay? But again, for the first time, let's implement that with the k equal 3. Okay, but actually you can change later. Okay, it means you are defining first 3 shortest distance for k in. After that, you have to use the scale train. Scale train is means the process before that you have done the standardization and you keep the standardization right in the training scale train. Okay, and you fit it with the function fit. Okay. After that, this line is mean you are training the model. Okay, and this line is mean you are use the model trained with your scale test. It means 30% of training you keep. You want to predict. Okay. After you predict, 30% of the model is around 131 questions, right? You keep 30%. So after you get the Y predict, okay, you can make the data frame for showing your predict answer and the real answer. So this one is the output of both coding. You can see that this is the Y predict and the actual Y. Okay. For example, the predict as 0 and the real one as 0, so it's been correct, right? It's been correct. 0 is mean positive, right? And I forgot 0 is mean positive. 0 is positive. 1 is mean negative. Okay, refer to the table here. Yes, test positive 0 and negative is 1. And this is the predict as 1 and the real one as 1. Okay. And you can see some data you have test like the 200 around times, 200 times around. So you can see that sometimes is wrong, right? Because you are predict as 0, but the real one is 1. So this situation is being wrong. So in the 231 times, sometimes they got the wrong answer, sometimes they got the correct answer. So if you want to measure the accuracy of your models, you can use the scikit-learn.matrix import the accuracy score. Okay, the accuracy score function. And if you want to get the confusion matrix, you can import the confusion underscore matrix here. And also, if you want to see the summarize of your model, you can call the function of the classification report.
So,
if you print out, you can see the accuracy of the model around 0.68, but it is 68 accuracy, 68% accuracy. And the confusion matrix shown here.
accuracy score.
The classification report is will be report you the detail of each class, like the prediction, like the precision recall and F1 score. Okay, and you can see that this is the class 0 and class 1. Okay, and class 0 is refer positive, right? And it has the precision recall F1 score like this. Okay, and this is the support. This means like how many times you test, like 147 questions to ask the model. Yes. And this is the detail of accuracy of macro and weight accuracy. Okay, so this is the example if you want to predict. Okay, let's take a look a little bit like I will change this one because like this the accuracy is around 68%, right? But what happens if I change the model as 5? For example, I change the number of gates at 5, I run it again. Okay, I run it again and I will show the yes. As you can see, the accuracy is a little bit higher than the original, the previous one, right? It's from 68 to 71, right? And what happens if I change it again? I will change number to 11. Okay, if I change it to 11, a little bit different from previous one. Yes. So you can see that the number of k is affect to the accuracy. Even you use the same data set, same test, but it's different. Okay, so the homework. Okay. I want you to do the homework in the question 6, 7, 8. Okay. Please finding the solution for finding the suitable of number the k number. Okay. The concept like
Triumph.
okay, I want you to run by using k from 3 until 20. So it means the output of the, for example, if you talk about the graph output, you can see that the x-axis is in k, right? And you will run the k from 3, 4, 5 until 20, right? And y-axis it refers to accuracy. Okay. So every time you test the model, you will change k equal 3, 4, 5 until 20, right? So you get the accuracy with the different value. Okay. For example, if you get the graph something like this, you can tell us about the highest accuracy. For example, if you get the highest accuracy here, you can know that okay, we should use the k equal 10. For example, it means because when we use the k equal 10, we can get the highest accuracy, right? So this is the 6, the question 6. Okay. After you know, like for example, if you know that the k equal 10 is the best one, please show the accuracy and confusion matrix. Okay. Of your select the k number. Okay. Okay, and the last one, let's study the function for k for cross validation. Okay. As I taught you in the slide here, okay, it has a function. You can search in the internet or talk to the ChatGPT about the cross validation. Okay, and let's do it in the question 8. Okay, the example of the cross validation. Okay, you see the homework. Okay, maybe the homework 6 you can do like the for loop, right? Use the for loop and change the parameter k in every time you run it in the loop. You can find the accuracy and change the k for loop. After that, you can plot the graph. Okay.
Could you turn to the fifth part, the prediction?
Which one? This one?
Yes.
Yeah, this one is the prediction. For example, if you input your parameter or your feature, like how many times fatness, glucose, blood pressure, like this, okay? For example, if you have the model and you have the new patient who come to your hospital, right? And you just input the parameter of that patient, you can predict the answer. For example, if you have the data set like this, maybe your model is going to predict that, okay, you have the negative output for the diabetes. Okay? Actually, this one we call binary classification. Binary is only two answers. And if you have more than two answers, we call the multi-class classification. Okay. Multi-class classification, like you have the many answers of your prediction. Any questions? If you have no question, finish today's class. And the next week we will go to the topic of the artificial neural network. It's more quite advanced and complicated in terms of the calculation. Maybe I will show you about the calculation process in the background of the neural network. That you understand why when testing the neural network or the deep learning, why we take a long time, because it has complex mathematics background. We have like the feed forward is the step of calculation to get the output, but you know the output might be wrong for training process. If it's wrong, it has to do the back propagation, we call the process that calculate and update the weight one by one to get the better model and then we test it again with the feed forward to get the output. But maybe the output is still wrong with the some small error. You have to adjust it again. Back propagation, feed forward, back propagation like this. It's quite a little bit complex. Okay. See you next week.
Yeah.
What did you travel or?
That's right.